Good day, colleagues. My name is Marcus Dekena, and I'm co-chair of the Load Research chapter. Today we have a presentation on transmission demand forecasting for you. The title is Demand Forecasting for Eskom Transmission Network Planning in a Rapidly Evolving Power Sector. The presentation will be given by Jana Breedt. Jana is a B.Eng with an honours in industrial engineering, and she is Chief Advisor of Demand Forecasting at Transmission Grid Planning, Eskom. She is currently busy with a Masters in Industrial Engineering part-time at University of Stellenbosch. She is registered as a professional engineer at the Engineering Council of South Africa and is a full member of the South African Institute of Industrial Engineers. Jana started her engineering career in quality management and business engineering, but fortunately for us, she veered into the specialized field of demand forecasting and planning functions within Eskom. She now holds a position of Chief Advisor, Demand Forecasting, where her main responsibility is to provide national, regional and transmission substation long-term demand forecast as input for the National Transmission Development Plan. Her interests include supply and demand management and future studies with regard to how the network demand forecast configuration will be changing in a rapidly evolving energy arena. And with that, I hand you over to Jana. Jana, the floor is yours.
Thank you for the introduction. I'm going to tell you a little bit more about the demand forecasting for the Eskom Transmission Network Planning in a rapid evolving power sector today, and some of the challenges we've been experiencing within the power sector and how we try and deal with the process to combine aspects into our demand forecast. So first of all, the purpose of the transmission demand forecast is to provide an overview of the national grid electricity demand in South Africa that serves as input to the Eskom Transmission Development Plan annually. This presentation will outline the changes within the power industry affecting the demand forecast, the base of the Eskom demand forecast methodology, components that we use to model the demand forecast, and application of the forecast and some of the challenges experienced. So planning for a sufficient energy resources in a country is of paramount importance to ensure a sustainable development of the economy and the prosperity of its citizens. Eskom is tasked to create an equilibrium between the country's electricity demand and the supply thereof. So this should be done considering the impacts of corporate governance, technological evolution, infrastructure development, regulation and competition, and corporate governments to ensure that we've got security of supply. If we look at the power sector currently, we know that the power sector is experiencing a serious paradigm shift. The fourth industrial revolution is imminent. So how do we need to adapt as engineers and forecasters? Is our current forecast method still applicable? We ask ourselves. How will renewable energy utilize the transmission grid capacity? And will the demand change, or will the supply to the demand change? So I find myself asking network demand forecast to be or not to be, to change or not to change. And then we have a closer look at how we need to adapt our methodologies and how the power sector has adapted. So the turn of the millennium indicated the start of a new era in which of the fundamentals of the power sector began to change. Supply of electricity was mostly operated in a vertically integrated supply chain, and the utilities had most predictable load growth and therefore predictable sales, which is governed and periodically adjusted to keep the utilities fairly profitable. However, these days we find ourselves that the vertically integrated supply chain has more changed around to a horizontally integrated power supply chain, where we've got the integration of the IPPs and embedded generation, and we now have to see how we service each of our clients within this new set of supply chain in our evolving power sector. The industrialization brought technological leaps, which led to a paradigm shift, which today is referred to as the Industrial Revolution. So this took us from the first revolution, from mechanization, to the second, of where we had intense use of electricity, then to the third, where we had a lot of digitalization, and now we're heading into the fourth Industrial Revolution, which some might argue we've been propelled into in the last couple of years. If we look at some of the technological advancement, we can see that there's a lot of unpredictability, and some of the areas which we currently feel is unstable and unpredictable is actually some of the more stable and more predictable areas. If we head into the future with new smart home system, battery system, bridging technologies, all of the different smart grid applications into the future, gets even more disruptive and more unpredictable. So if we look at the Eskom network and the Eskom network forecasting landscape, we traditionally had a base landscape where we had our generation, our grid, which we supplied to, which led to supplying our local load that we needed to. This was basically enabled by the Eskom environment, where we had generation of our conventional coal, our nuclear and hydro plants, our cogeneration plants. This then led to feeding our transmission grid as well as our distribution grid. And this then, through those grids, serviced our loads. However, moving into the future, we now have additional generation sources, such as the renewable program, which offers wind, solar, and CSP. This is also moved through the grid and then feeds the load. If we look at our future landscape, we can see that we still have our base generation, our grids, and our load that needs to be fed. However, we now have an additional landscape which is formed by the off-grid solutions. So this is where we have got our own embedded generation and microgrids, as well as self-generation PV, rooftop embedded generation, and other additional sources. So these are also transmitted to service load. Some of it can be used to transmit through the grid, and some of it is actually servicing the load directly. However, some of them actually feeds directly into the load, but as soon as there is an excess of what the load needs, it can actually feed back into the grid. So this poses a new challenge to where we look at the demand forecast and what the actual capacity on our network should be. Should it be increased due to the increase of generation at certain points, or should it only be focusing on the load that we forecast so that the modeling solutions can be modeled around that? All right. If we look at our evolving power sector and the change that we have in our forecast landscape, we know that there's a couple of disruptive or enabling technologies available at this stage, which influences our country's spatial electricity demand. These then has an influence on our grid demand forecast and, of course, our generation sources available at this stage. Also, we need to ensure that we know how do we incorporate these integrated generation sources and what is the impact that they have on the grid demand load forecast that we have. What we've seen on our customer base side, if we look at our traditional conventional customer base, we mainly had grid connected customers and cogen grid connected customers. All of these customers has a national grid capacity that need to be serviced, and they related to an amount of sales that we needed and we got from them. However, moving into the future, our new customer base is fairly based on grid connected, grid tied customers and some off-grid solutions. What we've seen already is that there's a drastic reduction in the energy usage or the sales needed to supply these customers. However, the grid that's still needed to supply these customers is still has reduced slightly, but not as much. So the demand has reduced because of these different connections in our new customer base. However, the actual grid capacity and the forecast landscape has not changed that much. There's still a certain base amount of capacity needed to service our clients from the grids. As soon as they are up, even if they're grid tied, a lot of them implicates that they are grid tied, meaning that whenever the sun does not shine or their solutions is not in place, they would just default back to the grid. And therefore, we need to ensure that there's enough capacity available for these clients. Right. So what we're considering is that within the forecasting landscape is that in the current situation, we've got our national grid dependability. So from my perspective, servicing the national grid, which is the transmission grid forecast, we need to know what is the amount of customers that we need to house within our network environment and what is the demand needed from the utilities national grid forecast. So at the current time that we have and our current national grid forecast scope comprises out of a full grid utilization customer base, which is the majority of our customers. Then there's a small bit of variable access to the grid, people that are grid tied, and then there's a very small area that is actually off grid. However, going into the future, and this is not numbered, it's not quantified because we don't know exactly, we don't have enough quantitative data to predict this accurately. So this is just a conceptual graph showing us that we might end up into a situation where people using the grid on a full-scale basis is reducing. The variable access can either increase or decrease, and the off-grid solutions, as soon as technology comes into play, better battery storage comes into play, we can actually see that there is a majority of people moving over to off-grid alternatives. So we need to take all of this in consideration so that we do not forecast a full-on demand and then assume that the current utility will take care of all of that energy needs. So we need to distinguish clearly in our scenarios which of these scenarios is the utility facilitating all of the energy sources in the country, and which of it there will only be a role player. And that is where we differentiate between our different scenarios when we do forecast. So some of the techniques that we have already been applied in Eskom in the transmission demand forecast, there's some traditional forecast methods, intelligent forecast methods, and strategic methods. Not all of them has been applied fully. We've got our transmission demand forecast process, and there's a couple of these demand forecast techniques that is already applied, and some of them that can actually still be applied going further. So this is what we've analyzed from a theoretically point of view, and we need to focus more into complex theory, systems thinking, and scenario planning going into an uncertain environment into the future. So we're looking at a proposed forecasting framework for the future. So we are looking at the current transmission demand forecast process, and we need to identify the disruptors in the demand forecast, which we've already done. And then we need to look at future modeling applications on the demand forecast. So this is what we will be focusing on in the time to come. And we are trying to focus on scenario planning approach, looking at multi-criteria decision making, and then we are still investigating different modeling frameworks. So for now, we still have our demand forecast process, which I'll take you over now. It is questionable at this stage, going into the future with a lot of uncertainty, and we need to bring in smarter models, including all of the difference. So what we're saying is, in our forecast methodology, I'll quickly take you through what we're currently doing. We say we're moving into an uncertain and evolving future, and therefore scenario planning approach for an uncertain and fast evolving future is appropriate for now. So our approach that we take is that we start on the wide eye from an industry perspective. We try to understand the evolvement of power industry. We try to understand different perspectives associated with it. We try to clearly distinguish between the history from the future and acknowledge the change within that. We try to consider future alternatives and growing trends. We understand the local and the global economic events and how these are linked to the energy trends within our local possibilities. We also try to consider major trends beyond our control and how they influence our forecast. So if we bring it a little bit closer to home, we try and focus on considering major trends beyond our control, which is the technological progress and the economy and the technology that we need to look at. We also look at considering future trends of urbanization, transportation, and the choice of energy source, which is quite an important point at this stage. With all of this, we still consider our governance and our policy guidelines, which is mainly the National Development Plan and the Integrated Resource Plan, the IRP, coming from the DOE. So in consolidation, this is basically using analytical aspects and both social aspects and combining them by using quantitative and qualitative forecasting applications to try and form our forecast going forward. So the main transmission forecast process that we currently use and its components consists out of these couple of steps. So we do a top-down forecasting. So we start at a national level and bring it down mathematically into provincial and into a transmission supply areas. We do some base demand analysis where we gather actual demand figures. We look at our network topology and updates, and we look at research on technological advancements and its influence on the forecast. We also try and bring in market intelligence where available, where basically we answer what is happening, where is it happening, how much electricity is needed for it, and when can we expect the growth in that specific area. We do this by looking at our indicative and budget quotes that we receive from our customers, macroeconomics, development, and investment monitoring on the microeconomics as well. We incorporate all of this information within our mathematical model where we build our forecast assumptions and formulation, and then we use a transshipment model to use nodal balancing from a top-down approach. where we then balance the top-down scenarios. Then we go over into a validation and alignment phase, and this is where we use both external and internal forecasts to do some alignment within Eskom, and also with some of the external forecasts that you get from GDP, IRP, NDP, the CSIR, and so forth. And we also do alignment of forecast internal to Eskom, where we actually have a bottom-up, top-down, bottom-up alignment process in place. And then, of course, there's the implementation of the forecast, where we actually give input to the transmission development plan and we track our accuracy. So I'm going to quickly go through each of these steps and show you more or less what it is that we do in each of them. So from the top-down forecasting approach, we basically take it down from the total Eskom country load, which has also gone from 97% down to about 91% into the future. So this change and is interchangeability, and we need to constantly track where the load is moving. So you do get that load will move from different areas in the country. Typically how the mineral resources moves, if mining is moving from the Northwest Province towards the Polokwane or the Limpopo province, then you can see that there would be an uptake of the manufacturing and mining sector in that area. So we constantly track the sector contribution as well as the load contribution within the country and balance our nodal points out in such a way. We also look at our base demand analysis, which is our second step in our process, and where we look at our actual figures, we trend our figures and see how far they go. And we also need to look at the entire picture of trend time cycle. So you've got a forecast, and the formula for that is trend time cycle, which we have a definite trend, which is normally the S-curve trend that we use. And then, of course, you see cyclic deviations around that central trend, and we need to track that in real time with the actuals to see how we are featuring and how we should go into the future. Right. So we have seen that from the past we have gone into a paradigm shift, and we've adopted our S-curve model, and we have actually done some regression analysis on our actuals to track our accuracy, and we noted that we need to change our S-curve, and we went over into, typically at that stage we went over into a double S-curve mode, where we need to slightly adapt closer towards the actual numbers that we do have. Right, so we keep our tracking accuracy on that, and as you see, as we've improved our model, our accuracy has improved with that as well. So as part of our second step in our base demand analysis, it's also important to understand the new dynamics that we sit with the IPPs coming in and playing a role in how we actually look at our base demand data. So what we've seen is that we've got a typical MTS supply area where we've got base Eskom metering, and then there is IPP metering coming in at that MTS. So you've got a certain amount of your load being serviced by additional generation. Therefore, it's important to have the real picture of the real current load at that specific supply area, that you need to consider all of the different aspects, and to make sure that these different aspects that you have that plays a role into your demand, to make sure that you balance them out, that you can see the actual demand that you need to service within your grid load forecast area. So what we typically have is a supply area. We've got an IPP in that area, so that adds generation to that point. So what we need to do is we basically have an Eskom metering, which is typically lowered by this additional generation at that point. We need to add back that specific generation so that we get the full MTS base load picture, so that is our starting point of the actual load that we need to service. Another example of that is where you can look at, this is a day profile for a Northern Cape substation. This is our historic profile that we had. If we look at a current profile, you would see that suddenly the Eskom metering side has a lower demand measurement, especially during midday where the sun shines quite brightly. So if we consider the IPP metering at that specific point, you can see that there is a definite decrease in the Eskom metering due to the IPP measuring in at this point, or providing supply to that specific spatial area. So what we need to do from a demand perspective to know what is our actual demand on that supply point, spatial supply point. We need to add back that to get the resultant load. And this is where we get our resultant demand, and this is then seen as our true load profile, which you can use before if you use it as only load. But it's important that we need to understand these dynamics and make sure that we handle each point correctly, and make sure that you use the correct IPP data together with the Eskom metering data to ensure that you've got the correct supply-based data to start off with. Right, this is just showing that it then resembles more or less the historic profile before IPPs came to play. So this is some of the challenge that we experience, and we need to make sure that we have the right maximum demands for that specific area. So looking at our market intelligence, there's a couple of different sources that we look into incorporate into this. Our Eskom direct customer base, which is our metropolitan, main metropolitans, is quite a big portion of our load. So we try and focus to get their forecast correct and get some inputs from them to actually include it into our demand forecast. We look at our sectorial forecast analysis. We can see that all of the economic sectors is still growing, but in a different combination of growth. So you'll see that less energy intensive sectors tend to have a higher growth at some point, and some of the more energy intensive sectors tend to slow down. So that has an impact on the amounts of energy intensity that we're looking at going into the future. We also have a close eye on what the investment conference pledges is, and where we can see that because we all know that there's demand, but we really need investment to enable that demand. We balance all of this into a mathematical model, where we have a node analysis relevance tree, where we take it from the top all the way down into our MTS areas. So that brings us to the result of that nodal balancing, brings us to a provincial or MTS forecast, and this is where we need to go over in our alignment phase, which is the fifth step in our process, which is our validation and alignment. So as I said previously, we take a top-down approach, and then we need to make sure that we actually align with what is happening in the rest of Eskom, as well as on the bottom up from the distribution side. So transmission takes it top down, and we look at global, then national, and bring it down to MTS level, whereas distribution takes it all the way up from the distribution substations or customers to MTS level. And this is where we need to get our alignment done. We make sure that we are aligned in topology, customer strategic information, and our network plans and case file design and forecast, obviously. So there's a couple of governance areas that helps us to govern that and to get alignment between this. We also use the GLF tool. We analyze it from there so that we can, on the same platform, look at both the transmission and the distribution forecast. So basically, we get our bottom-up information from the GLF source, but then rework it into our sources, as we do not forecast from the GLF specifically, but the bottom up does. This is where we use our alignment. Then, of course, our implementation of our forecast this is where our final product goes into the national demand forecast for the transmission capacity planning, which is a 10-year rolling period or 10-year TDP rolling period plan that we need to give it in every year. And the transmission development generation assumptions gets built from this, and also we provide some SAP power pool support into the Southern African power pool modules, where they also use this for master plans. So this is the application of that. So just to give you a application example of where our demand forecast is. So we've got our base demand forecast. This is typically what goes into the transmission development plan. We've got 3 highlighted scenarios that has each of them has a different set of assumptions and takes us to a different target network. This is relates to a different growth perspective in each of these scenarios. This is also benchmarked with our budget quotes that we receive and our indicative customer quotations that we have, as well as extra market intelligence. If we assume no growth at any stage, no further growth, and we just take the applications, we can see that there is actually a demand in these different these different provinces, where we can actually see a growth that is out there. So this is actually from actual budget quotes received. So there is showing us that there is a definite demand. We need to be able to service that to enable that growth in our country. Looking at extra additional market intelligence and unconfirmed applications, we can see that there's definite growth out there. Right, so this is part of our validation. Then lastly, we look at our IRP and we validate what our forecast look like against the IRP and the national plans. Right, that is me.
Thank you, Jana. I see you used the National Development Plan as one of your inputs. What's your perception at the moment of how South Africa is going in accordance with that National Development Plan?
Okay, so I think that's an important question. And it is something that I'm toiling with quite a couple of times. So the National Development Plan still seems like one of the main governance policies that's been put out. It has not been revised since 2010, or it's been released in 2013. So we know that there's been a lot of water under the bridge since then. And we know that there's been a lot of additional technological advancements going with that. So yes, on the one hand, it still has, it still gives us a target network for, at that stage, it actually mentioned that we can grow up to 65 gigawatts in our network capacity, which is almost double from what we currently have. And at that stage, it was still targeted at 2030. So what the assumption originally was, by keeping that, is that we assumed a lag of implementation for about 10, now more to 20 years. And then for that, we used that target network and shifted it out with that assumption. I do feel personally that that is the target that we as a country can actually reach. So there's still a lot of opportunity. There's still a lot of minerals in our ground. There is still a lot of growth possibilities, and we need to move from a developing country to a developed country, and that would give us that end state. However, I think in the meantime things has changed, and most probably, I don't know if I'll be penalized for saying this, but most probably we're moving into a more competitive environment. So should you have one utility sourcing all of the supply in a country, we will probably still get to the National Development Plan. However, I think the IRP has also cleverly shown that in going into the future, we'll have more of a market environment where we've got people playing into the energy market, and you'll have different sources, whether it's on a personal or on a public basis, and whether it comes from a utility or it comes from private initiatives that generate some of the power in our country, and which enables microgrids as well. So they would probably, going into the future, you'll have a distinction, and I think that's where Eskom need to clearly note what is happening and make sure that from a forecasting point of view, that's my challenge, to say how much, and that's the one graph that I showed, that we going into the future, we might see a different portfolio of what we should be able to match. So probably Eskom would become a role player within that 65 original National Development Plan, but not all of it would be serviced by Eskom itself. The assumption when it was written in 2010.
Thank you, Jana. Another thing which is kind of interesting and fairly current, what is your sort of short-term view of where the demand is going, given the coronavirus response that South Africa has put up? Can you perhaps comment on how many months you see that going on and what you expect the load effect might be?
So that is a difficult one to answer as well. I'm trying to track that as we go along. We've already seen a lot of different opinions and different things unfolding since the corona started. So since we started straight out, the expectation was that we'd have a month-long gap and then we just rebounds back to full capacity. However, now it's dragging along quite indefinitely at this stage. Although we've got ramping back of some of our clients, there's a lot of implication on the demand, was that a lot of the mining and manufacturing and downstream supply chain from that was affected due to the mining not being able to operate on only half of its magnitude. So you saw a lot of large customers going into care and maintenance mode. The effect of that seems to be that it will definitely affect 1 or 2 years. We're expecting a decrease in demand once again. And I think a lot of that was implicated by this. A lot of our customers goes into care and maintenance in winter time, where we have our high tariff. So that's tariff related. So what happened now is they were forced to go into care and maintenance before they went into their official yearly care and maintenance period. So what a lot of them did is they just didn't bother to ramp back up before that period. So they just decided to cut off the rest of the month, and they would then definitely lower their demand for the total year. So there is definitely an operational shift that we're seeing. The question now is how many of these guys would be able to financially sustain themselves and come back as businesses. So we do have a chance of losing some of our clients and therefore losing demand on long term. We also do have the situation where a lot of them will be ramping back up. It can be either directly as the lockdown is lifted, or some of them might come back periodically as they normally do. So in a lot of the analysis from an economic side, a lot of the forecast hints towards a sharp negative contraction within the next year or two, and then a kind of quick recovery from 2021-22. I'm not exactly sure what the effect on the network would be from that perspective, but I do, however, see that the effect is larger on the energy side rather than the capacity side. A lot of these guys might come back straight on full capacity, but might not operate for the entire duration, and therefore reducing the energy usage, but not the actual connection capacity.
That's a very interesting insight. Thank you so much for that.
Thank you.
And thank you very much for your presentation. We hope to see you back at some stage in future.